In this question, to find the surface area of this rectangular solid, we will most likely require all three dimensions, the height, width, and depth of the shape. We can call these three dimensions A, B, and C, so that the surface area would be 2AB plus 2AC plus 2BC. Let's move on to the data statements separately first. Statement 1 tells us about two adjacent faces. They have one dimension in common. We can interpret this as AB equals 30 and AC equals 45. The dimension in common is A. That gives us a total of two equations and three variables, so we cannot solve directly. Meanwhile, we don't know BC. We can imagine a case in which A is 5, B is 6, and C is 9. Then BC is 54. In another possible case, A is 15, B is 2, and C is 3. Then BC equals 6, and since the two cases have different BCs and equal other areas, they have different surface areas. Statement 1 is insufficient. Statement 2 tells us that ABC equals 270. So we could have A equals 5, B equals 6, and C equals 9 once again. Or, in another case, we could have 27, 10, and 1. In the first case, half the surface area would be 129. In the other case, it's greater than 270, so it's clearly different. Once again, we have two possibilities, and statement 2 is insufficient. When we combine the statements, we now have three equations and three variables we will be able to solve completely, and the single possible case turns out to be the first one that we've examined in each of the data statements. This is not a complete surprise, as it's allowed by both, and when a possible case is allowed by both data statements, it might turn out to be the actual case. Together, we have sufficient information, and the correct answer is C.